All right, good morning everyone. Today we're going to talk about the unit circle. The unit circle is a basic circle, so please try and recall all of your information that we learned about circles in Math C. We talked about them a couple different times. Getting my color scheme ready to go. So the unit circle is a circle that's centered at the origin. Well, let's think. What is the origin? Good, it's that point 0, 0. And it has a radius of 1. Well, if the equation of a circle, of a basic, just any old circle, is x minus h quantity squared plus y minus k quantity squared equals 2r squared. And that is the general form that we learned last year. And we talked about how h comma k was the center of the circle. I'm going to fix that k because it's a little meh. And not only is that the center of the circle, but this is opposite of what we see in the equation. Because if you notice, up above, maybe there we go, my h and my k appear to be negative, but we need to remember that we're going to do whatever the opposite is that we see. So if they're negative in the equation, they're actually opposite. They're positive. If they're positive in the equation, they're opposite, and they're negative. So let's go ahead and continue that sentence. So the equation of the circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared, where hk is the center of the circle and r is the radius. So essentially, in that case, it's the square root of the number in the equation. So it might be equal to 25. The actual radius of that is going to be, good, 5. It's the square root of whatever number we see equal to. So let's go ahead and plug in our numbers because we're going to derive what the actual equation is of this unit circle together. So if I know that my center is at 0, 0, that means that my h comma k is 0, 0. So where I see h, I'm going to plug in 0. Where I see k, I'm going to plug in 0. So I have x minus 0 squared plus y minus 0 squared. And what was my radius again? What was 1? So we can go ahead and substitute 1 in for that r as well. Well, that's a little crazy. That's got too much stuff in it. We like to simplify things down as much as we possibly can. So let's take a look here at that first set of parentheses. What is anything? Doesn't even matter. It's x minus 0. What's anything minus 0? Well, it's essentially just itself, isn't it? So this can go ahead and turn into parentheses x squared. Because remember, my order of operations tell me parentheses first. So I have to do whatever's inside the parentheses first. So I took that x minus 0. I got x. Let's take a look at that second set of parentheses. What about y minus 0? What is that going to be? Well, it's the same. It would just turn into y. And there's nothing else on that other side of the equation except for that 1 squared. What is 1 squared? Well, essentially, it's just 1. Okay. Well, instead of having x in parentheses, can't I take x to the second power? Well, what is x squared? It's just plain old x squared. What about y to the second power? Good. Just also turns into the y squared. and 1's just going to stay 1. So the equation for the unit circle is simply x squared plus y squared is equal to 1. And we derive that by simply plugging in the origin and the radius. Okay, let's keep going with recalling all of our circle information because we know that it's going to need to happen and help us with stuff. So let's talk about circumference. The circumference of the circle is found by using the formula C equals, who can remember what that one was? Good, 2 pi r or pi r, or 2 pi r or pi d, but I'm going to go with a 2 pi r. Well, because the radius of the unit circle is equal to, what was the radius again? Right, it was 1. Because it's equal to 1, we can go ahead and determine what my circumference is going to be because I have that missing piece. I have that variable. So let's plug it in. So I have 2 pi times my 1. We know that we like to leave things in terms of pi unless it specifically tells me to not leave it in terms of pi, or it'll tell me to simplify or round to the nearest number. Since I don't see anywhere in my directions that talks about rounding, I'm going to just leave everything in terms of pi. So that means that I can scooch over my 1 and put it next to my 2, because we know multiplication can be moved around. 3 times 4 times 2 is still the same thing as 2 times 4 times 3. Alright, what is 2 times 1? It's just 2. Since we're leaving it in terms of pi, the circumference here is going to be 2 pi. So that means that it takes one whole rotation around the circle is going to be equal to what's called 2 pi, and that is a value. I know it's weird. It's working in those radians. We didn't really like those last year, but we got to get a little bit more used to working in radians. Now let's talk about degrees here for a second. When we talk about a circle in degree, one full revolution, or one rotation, or one whole way around is how many degrees? Well, that's a simple 360 degrees. Good. If we split that circle into 4 equal parts, then each corner angle that it creates increases or goes up by how many degrees? So essentially, what is 360 divided by 4? It's going to give me 90. Well, what does that look like? Okay, so if I go up by 4s, or I split my circles into 4, we know that each corner here has to be a right angle and has to go at 90 degrees. Now, I'm not going to put my right angle symbol in here because I'm going to do a little bit more still with this circle to our right. So I don't want to draw that in here, but I want to talk about it. About how, since we're splitting it equally, we're going to create 4 90-degree angles. Well, what happens if I wanted to split my circle more? Because, I mean, I'm not just going to go and talk about things in 90 degrees, because things don't happen at 90 degrees. My steps don't go up 90 degrees. Oh my god, that would be terrible. My mountains don't go up that high of a degree. Well, let's talk about something a little bit smaller so it's a little bit easier to see. What about when I split into 8 parts? Well, half of 90 is what? Good, 45. So my new angles on top of the red ones, my new spaces here, will go up by 45 degrees. What happens if I split my circle into 12 equal parts? Now, when we split it in 12 here, my blue lines won't matter anymore because they won't add up correctly, but my new color and my red will. Those ones will go up by 30 degrees. And I realized I did my colors backwards, I'm sorry. So, we have talked about the equation for a unit circle. We have talked about finding its circumference in both radians and now degrees, because we know a whole circle consists of 360 degrees, or 2 pi. We've talked about splitting it into equal 4, 8, and 12 pieces, and how, logically, it's just dividing. If I were to take 360 divided by 12, I'd get 30. So all we've done here is nothing necessarily new, just a little bit different of looking at a circle. Here's where still not necessarily new, but here's where the looking at my circle part comes in. This is the different part, the really big key part that we're going to talk about today. You should see on your notes that you have a blank unit circle that looks very similar to the one that I just drew the slide before, with some missing coordinates in it. We know how to plot coordinates, right? We just go my x coordinate and then up to the y coordinate. What we're going to do is we're going to determine what these coordinates are based on our past experience with some of the stuff we just learned and some of the stuff that we did in Math C. So that's why we're going a little bit slow, so it's not too crazy of a first unit. I want to take a look at my easy points. And what color did I use? I used, I think that one was supposed to be red, that first section. Yes, red. I want to try and stay with the same colors. So I want to talk about my main basic points when I split it into 4. These are the ones I really am going to want you to know the most, because these 4 are the most common points in a unit circle. And these points, no matter where your unit circle is, will be the same if it is a true unit circle. So let's talk about point A. I drew my line a little bit into it. We know it goes x comma y, and we know that my circle has a radius of 1. So wouldn't that mean that from the origin to A is the length of 1 unit? Okay, so isn't my x value here then just 1? And I can't fit it in those lines, I'm not even going to try. Well, then what's my y value? If my red lines are my axes, my x and y axis, have I gone up any? No. So it's just 1 comma 0. All right, let's go 180 degrees across from that. What about point E? What is point E going to be then? Using that same logic as to why point A is 1, 0, what is point E? Well, we're going negative, you're correct. So because we're going backwards, sorry, we're going backwards. It's opposite for my camera. Because we're going backwards, what happens when I go backwards? What are my points? They're negative. So this has to be a negative 1 comma 0. Okay, let's see if we can continue the pattern. What is my point C going to be? It's sitting on the y-axis now. So that means my x-coordinate is 0, and I went up a whole value of 1. Just like how I went to the right and left 1, I'm going up and down 1. So if that one's 0, 1, point G therefore has to be 0, negative 1. I mean, it makes sense, right? We're sitting on the origins. They should have 0s and 1s, some of them negative, some of them positive, depending on where I am in the axes. Okay. I think I did blue next for my 45s. So what we're going to do is we're not going to go to B or D. We're going to jump to point F because I want to look for a 45-degree angle since that's kind of the order I went in with our notes. And 45 has to be halfway through the 90s. Okay, well, if I look in the first quadrant, there's no point there. If I look in the second quadrant, there's no point there. So we have to go all the way down to F. So what I'm going to do is, and I want you to do this, and I can't draw straight lines today, so that was embarrassing, is I'm going to draw, if I can, a line from the point F to the origin. And it'll be easier to do on your papers than it is for me to do on my computer. If you want to get colors, now would be a good time to get colors. I meant to say that at the beginning and I forgot. So pause, please go get 3 different colors. 4 different colors, you need 4 colors. What we're going to do is we're going to create a right triangle here. So I am attempting to draw a perpendicular line from the axis to my point. The reason being is I know that between this 90-degree angle and this 90-degree angle, halfway has to be 45. So I want my 45-degree angle to be here. So logically, that means that this cannot be 90 here if I'm not drawing a perpendicular line. I'm drawing it up to this axis. Well, if this is 45 and this is 90, my sum of triangles tells me that this interior angle also has to be 45. We did stuff with 45, 45, 90 triangles. What? So with a 45, 45, 90 triangle, we know that since my angles are equal, the sides across from the angles are equal. So this side and this side have to be equal. The third side is going to be that equal side times the square root of 2. So if we're looking for the big side, so in this case our hypotenuse, because in all of our 45, 45, 90s, the big will be our hypotenuse. You take the small times the square root of 2. And we did this at the end of the year. So this should hopefully not be too terrible for you. If we're going to take the small, if we're looking for the small, we're going to take the big, and we're going to do multiply by the square root of 2 divided by 2. You're probably saying, well, whoa, I don't have any numbers on here. How do I know what anything is? Well, we do know something. What is the radius of my circle? 1. And we know that a radius has to lie from the middle of the circle to any point on the outside. So doesn't that mean that that blue line that we drew, the thinner one, the very first line, have to be a unit of 1? A distance of 1? If that's 1, we know that our coordinate points are my x value and then my y value. Aren't those the sides of my other triangle? So I can determine the coordinate point for F by using my 45, 45, 90. Well, what is 1? Is 1 my big side or my small side? It's my big side. So I'm going to take my big side, which is, in this case, 1, times the square root of 2 divided by 2. Well, what's 1 times the square root of 2? What's 1 times anything? It's just itself. So both sides are a distance of square root 2, too. Now here's where the logical thinking part has to come in. My x value, is that going to be positive or negative? I'll scroll down and get it so I don't write in my picture. My x value is going left or right? Am I going left or am I going right in this case? Okay, so you say left. Is left positive or negative? Left has to be negative. So that means that the x-coordinate has to be the square root of 2 over 2. Let's talk about the y-coordinate. Am I going up or down? I'm going down. So what happens to my sign if I'm going down? Am I positive or am I negative? Good, we're going to be negative again. So this coordinate point is negative square root of 2 over 2, comma negative square root of 2 over 2. And that is a physical point, and that's going to mean something here in a moment. We'll get to that slide afterwards. But that is the physical point on my unit circle. And the great thing about all of my 45 degrees is that there's some variation of this. They're either both positive, positive, negative, 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 positive, negative. It's pretty cool. Let's go ahead and take a look now at point B. So we're going to start exactly the same way we did the last one, creating a 90-degree angle to the closest axis. Okay, well, if I'm splitting my quadrant into 3 sections, and we know a quadrant's 90 degrees because we already talked about it at the beginning. Ignoring the middle one, because we know the middle one is 45 degrees. That's not even. We can't get to 45 evenly with 3. We're going to have one line here, and one line here. How many degrees is that? What is 90 divided by 3? 30! Yay! So we know that this little angle here is going to be a 30-degree angle. So then what has to be the angle by point B? It has to be 60. Didn't we talk about 30, 60, 90 triangles? Did. Okay. So with the 30, 60, 90, it depends on what we're looking at. Everything, my 60, I can't, that makes it sound like a lot. Let me try again. My 60 degree and my 90 degree angle can both be found as long as I have my 30 degree angle first, or the side across from it. This will determine both of these. If I don't have that 30 degree angle yet, I have to divide down to the 30 degree angle. So the 30 degree angle here, the side across from it, is what is really, really important. So if I have that small side, and I'm looking for my 60, so I'm going to look for, we're going to call middle, because 60 is my middle. If we're looking for the middle, we're going to take that small side, and we're going to multiply it by the square root of 3 in this case. It's a different number. Still square root, yes, but it is not the same as square root of 2. So we have our 30. We're looking for the 60. We're going to take that 30 side, whatever it is, and multiply it by the square root of 3. If we're looking for our large side, and we have our 30 side, we're going to take that 30 and we're going to take it times 2. So we're going to take that small side times 2. What about if I need my small side and I have my middle side? I'm going to take my middle, multiply by the square, multiply by the square root of 3 divided by 3. I know that's not written the best, so I'm going to try and rewrite it so it's a little easier to read because I see that my finger jumped. So we're going to take the middle times the square root of 3 divided by 3. Don't worry, I'm not going to leave my triangle yet. Now, if I'm looking for my small and I'm given the big number or the large, my hypotenuse, well, if I to go from small to large, I multiply by 2. I'm going to take my large and I'm going to divide by 2. Okay. I'm going to go ahead and remind us of what's our small, medium, and large. So my small has to be across from my small angle. So from B to the axis has to be the small side. Across from my 60 has to be my middle. So this one's going to be my middle guy, so he's going to be a little bit bigger. And that means that my large guy has to be across from the hypotenuse. Look at all those different size lines. So let's go ahead and start putting some numbers places. Again, what do we know about this circle? What pieces of information do I have? You're correct that my radius is 1, but where am I going to put that 1? I'm actually not going to put it on my middle side because I'm not going all the way to point A. I got really, really close, but I'm not actually at point A. So because that middle side is not all the way to the end of the circle, that can't be where my 1 is. But my really long side is, so I know he can be a value of 1. So if my really long side is a value of 1, and I need both my short side and my middle side, I'm just going to go ahead and follow my steps that we talked about over here. So let's go ahead and find that small side first. I'm going to scroll down a wee little bit so we have some room to write. So I have my large and I want to find my small. So we're going to use that bottom one. So if my large is a value of 1, and it says what 1 divided by 2, what is 1 divided by 2? Well, it's a half. But we're going to just go ahead and say it's a regular half. Boom! Easy. Not much work involved. Pretty nice, actually. Alright, so now I need to find my middle, and the only way to find my middle is to take my small times the square root of 3. So if my small is a half, I'm going to take that times the square root of 3. How do I do that? Well, I essentially have a fraction here. There's an invisible 1. And we know when we multiply, we do top times top and bottom times bottom. I'll label that. So 1 times the square root of 3 is just the square root of 3. 2 times 1 is just 2. So my middle is the distance of root 3 over 2, which I know sounds like a crazy number. Which is why we're doing these all by hand, because you wouldn't have any idea of being able to compute this with a calculator. Because it won't spit out that number. It'll give you a really crazy decimal. So which number is which? Which is my x value? Which is my y value? Is my small my x value or is my small my y value? Let's go back up in here and look. We know that our coordinate points go x, comma, y. So which is my x value here? The middle or the small? Good, the middle. And the middle was the square root of 3 over 2. And since we're in the first quadrant, it has to be positive. We went, sorry, I keep going backwards. We went right, so it's positive. What about my y value then? Is he positive or negative? Good, he's going to be positive. So that point there is 3/2, the square root of 3 over 2, 1/2. Now I told you we needed 4 colors. So far we've only used 3. We're going to do one more point because it is a little bit different, but the exact same idea of what we just did. Because if you remember, we only talked about 2 different special right triangles. We had 30, 60, 90, and we had 45, 45, 90. Well, we have talked about when my point is, I'm trying to find a good color that doesn't look terrible on here. We've talked about where the 30 is centered at the origin, but what happens when my 60 is at the origin? So we are going to take a look at point D now. And again, I'm going to start by drawing, that's way too close to red. Oh, I need a good orange color. I don't have good oranges on here, apparently. Do that one. Much better. We're going to start by drawing a line here from the point D to the origin. But I want to be picky this time of where I put my right angle. If you notice, D is still pretty close to C, which means we can't be in the 45 spot. This has to be a 30 or a 60. Well, if I connect my right angle to that C, it's going to be small. It's not far away. So that means it would have to be a 30-degree angle. But I just did a 30-degree angle. So in this one, I'm going to draw my perpendicular line all the way down to the x-axis to create that 90-degree angle that I want. Because I want this center angle here, a 60-degree angle. Okay, well, same idea. That's 60, then this little guy has to be 30 up here as I start writing a 6. A 2. Okay. So this guy has to be a 30 up here. Promise I tried making a 3. There we go. Good. So that means this guy over here has to be my short side. He looks pretty tall, but this tall guy is my middle side because he's across from the 60. So this guy has to be my long side. Well, we just talked about this. We have all of the information right here in green for this new side. So where does the radius go? Where's my 1 going to go? Good, it's going to go up here. So that means this is a radius of 1. Since he's a radius of 1, that means that I need to find my small and my small and my middle side. So I have the large. I need to go down to the small. So here we're going to do it off to the side under here. So to find the small, I take it, whatever it is, and divide by 2. Hey, it's the same number! Woo! That's pretty cool. Do you think my middle number is going to be exactly the same then? Let's find out. So I take my small, multiply it by the square root of 3. We know there's an invisible 1 there. We get square root of 3 over 2. What? They're the same number? What? Well, I mean, it makes sense, right? They have to be the same triangle. They have the same hypotenuse. If they have the same hypotenuse, they must have the same sides if we're in the same triangle. But here's the kicker. Which one is my x and which one is my y? This time, my small side is my x. So my first value is actually going to be a half. And more specifically, because of where the point D is, he is to the left, so he has to be negative. But it's still the same point. That means that my y value, my going up and down value, has to be the square root of 3 over 2. But he is positive because he's going up. So some neat things to talk about that I want to write down. And I know you have some room off to the side, so make a nice little lovely star. And I'm going to type this because it takes a really long time for me to write things on with just my little finger. So bullet points that we talked about today. The main 4, my 90 degrees, are 0s, 1s, we'll do this in actual numbers, 1s, and negative 1s. My 45-degree angles are all the same. There you go. I switched those two words around. They are all, I have to draw this one. They're all some variation of root 2 over 2, comma root 2 over 2. Some are positive, some are negative ones, some are one of each. But they are all going to be that variation. .30, 60 degrees. We'll switch. Between the following two numbers. So it'll either be a half or root 3 over 2, comma, root 3 over 2, a half. So the main question is, well, how do you figure out what h is then? How do I know if that's a 30 or if that's a 60? Well, let's draw a triangle. Doesn't matter if I draw it there or there. No, not really. The reason being that it actually truly doesn't matter where that triangle gets drawn, because I can hear a lot of you say, well, how do I know which way to draw the triangle? Because on this first one, I went down to the closest axis, and on this one, I went down to the farthest axis. I could have, if I wanted to, chosen to go this way. I could have chosen to draw my right angle to the y-axis. It depends on where your degrees are. So, for example, this one's just up 30. So when it's up by 30 degrees or 30 degrees more, which isn't divisible by 60, right? 3 can't, you'd get a half, but it's not really what you want. You want a whole number. If it is divisible by 30, it's root 3 over 2. Okay, well, wait a minute. Well, this is 90, so 90 plus 30 more, because we talked about how all those ones are what? It's 120. It is divisible by 30, but wait. 120 is also divisible by 60. If it's divisible by both, you start with a half. So let's figure out what this one's going to be. Well, I have 90 up here, plus another 90 is 180, plus another 90 is 270. So I'm at 300 degrees there for this first one. Is this a 30 or is this a 60? Is this a variation of a 30 or a variation of a 60? Is it divisible by both? Since it's divisible by both, it's a 60. So it's going to be a half in the x spot and a root 3 over 2 in the y spot. Are they positive, negative, both? What do we have? Well, my x is positive, so my 1/2 is going to be positive, but my y is negative. So it has to be a half negative root 3 over 2. Now I'm going to pause this video because my phone is ringing, so I will see you back here in video 2.